In this example, we're going to solve a first-order differential equation using the Bernoulli equation. This is the Bernoulli equation for differential equations or first order. It's a photo of Jacob Bernoulli, of which the equation is named after. If you compare this with the integrating factor first order differential equation formula, you'll notice they look exactly the same, except for on the far right you have q of x times y to the n. So the methods for solving these two type of problems will be very similar. Let's go ahead and get started with our example. Y prime minus 2y plus e to the negative x y squared equals 0. Notice how every single term has a y in it. If you see an example like this, then there's a good possibility you will want to use this method. To make this look like the Bernoulli equation even more, you can move the e to the negative xy squared term to the right, and you might notice a similarity in what this looks like and the standard form for the integrating factor equation looks like. They look very similar to each other. And you can see how if you could just get rid of this y squared term, it would be very much solvable by the integrating factor. But it's there, and you can't pretend that it's not, because I wouldn't be solving the problem. So how we can proceed is, since this y squared term is what's really making the difference between solving this and the integrating factor problem that would look very similar to this one, is go ahead and get rid of the y squared term by dividing every term by y squared. And this is what it will look like after the division. Now, indeed, what we're going to do now is treat this as an equation of which we want to make solvable by using an integrating factor. To do that, we'll need to make a substitution, and what we'll do is we'll create a new variable, call it v, and we'll let v equal to 1 over y. And so it's just as easy to write v equals 1 over y. It would be better, though, because we're going to need to take the derivative of it, to write v equals 1 over y only using exponents. And once you've rewritten it, you can take the derivative. Now remember that v and y will both be functions of x, so that when you write v prime, you can take the derivative of y, but since y is a function of x, you need to tack on the y prime as well. And just so that we can get this v prime term to match the very first term of our example, what you'll want to do is divide by the -1, and then just, if you rewrite it as a fraction, negative v prime equals y prime over y squared, you'll see how you can make a direct substitution. So I drew the arrows of where you can make the substitutions, and you can rewrite this as a new equation using v's. Doing so would get you negative v prime minus 2v equals negative e to the negative x. Now we're going to need to solve this problem, and it's actually going to be an intermediate step. The solution to this problem would give us not the answer to our original problem, but it would make it easier to solve. And so we're going to work on this first order differential equation. This is what it would look like after getting rid of the negative sign at the very front by just multiplying every term by -1. I've actually already solved this problem as an example, and so what I'll do is I'll just rush through the steps of how to solve this problem in this particular video. But if you need help solving this ODE, I'll post a link and you can watch the video on how to solve this one. Okay, and once you solve for v, you should get that v equals e to the x plus c divided by e to the 2x. And this is when you need to recall the substitution we had made earlier. Now that we have the answer for this intermediate problem, you should remember that we had made the substitution to let v equal to 1 over y. And since we know that v equals e to the x plus c divided by e to the 2x, and it also equals to 1 over y, we can just set 1 over y equals to e to the x plus c over e to the 2x. Therefore, that allows us to go ahead and equate these two fractions equal to each other, and then all we have to do is solve for y, and that'll give us the answer to our original example. So you'll get that y equals e to the 2x over e to the x plus c, and you can go ahead and box that. Well, there you go. That's how you solve a first order ordinary differential equation using the Bernoulli equation. If you have any questions or comments, please post them below. I really would like to hear your comments, especially if you enjoyed liking the video. That way I know that this is indeed helping someone out. Thanks for watching.